Good morning. Today we are going to be covering section 2.3, solving compound inequalities. So you should have your pencil, your red pen, your ruler, your highlighter, and you should also have your cutout, which is the 2.3. And we can start once you're ready. Go and pause if you need more time to gather your materials. So first what we're going to do, we are going to move myself to one side first of all. And we are going to draw our line for the margin. So we're going to use how many spaces? 6 spaces should be sufficient. Let's see. If you have a larger grid, then just use only 5. So now 2, 4, 6. I'm going to draw a line all the way through using a ruler, nice and neat. And now let's go and write down the title. Your title is 2.3, Solving Compound Inequalities. Solving compound inequalities. And now let's go and paste your cutout right underneath. So you should have a glue stick with you. That's perfect. So just make sure that you glue it nice and on all 4 corners. You can do it just with your fingers. Just don't do it on the notebook, because you know what happens. You know what happened last time. I'm actually just going to use scratch paper that I have on the side. It's a little faster. Make sure you get your corners, and you should just place a big X in the middle. Line it up, and it's set. Sometimes you might have to do the corners once again, but this time is pretty good. So go and pause if you need more time. So we have a compound inequality consists of 2 separate inequalities that are going to be joined by an and or an or. So let's go and highlight. So it's going to be either an and or an or. So let's start with the and. The graph of a compound inequality with an and is the intersection of the graphs of the inequalities. So for example, on the first one, if I have x is greater or equal to 2, we know how to graph them, right? So in this case, x is greater or equal to 2. So we have a 2 here. Notice that the 2 matches. And in 2, 3, 4, 5. I'm going to place a 5 here. So therefore, x is greater than 2. That means that's going to go from here. Do we need to highlight the 2? Yes, because it's equal to. So in this case, I'm just going to highlight this part. On the next one, we have x is less than 5. X is less than 5. The 5 is here. Notice that there's an open circle. And we're going to not highlight the 5, but all the way to the left. And then you need to think, okay, which parts do overlap? Because it's one way and another. So therefore, we need to be able to find all the solutions that match both of them at the same time. So therefore, that'll be that section from here to here, correct? Because once you go over to 6, it's not highlighted here. And once you go over to 1, that is not highlighted above. So it has to be one and the other. So therefore, the ones that we're looking for are the ones in the middle. So therefore, that is how we graph ands. And notice that whenever it's an and, they're connected. So we are going to connect them every single time there's an and. And we'll work towards that. Notice that in this case, they flip the x. So even though x is greater than 2, once we come over here, it's x, we have to read it backwards. That part is read as x is greater than 2 as you read to the left. But we'll work on that. Now, whenever it's an or, it's one way or another. So therefore, if we have y is less than -2, and there's a -2 here, that means that it's going to be this section here. And y is greater than 1, there's a 1 here. It matches the one below. So therefore, all the numbers that are greater than 1 are to the right. And therefore, because there's an or in between, and you'll see the word or. Now, sometimes whenever you see the and, you actually will see the one, the one below. You'll see that one right there. Sometimes you'll see the one above, but most of the time you'll see them connected. And therefore, you need to be able to know that if it's connected, automatically there should be a and. But if there's an or, automatically, if it's an or, automatically you'll see the word or. And that means that it's going to be one way or another. If it's an and, should be crashing against each other, or should be always going away from each other. So repeat after me. And, crash, or away from each other. Ants, crash, ants, crash, or going away from each other. Something that you need to be able to remember. So let's go through example number 1. Let's go and solve and graph. And we have A and B. Now, write a little smaller because we're going to have 2 in one problem, and we want to make sure that we fit A and B. A. We have -3, which is less than x plus 1, which is less than 5. And we have B. For B, we have -7 is less than -3w minus 4, which is less than or equal to 2. And the way that we're going to solve it is going to be the same process that we've done before. But before we start, we need to think, is this an and or an or? Well, does it say the word or in between? No. So therefore we know that this is a and. So this one is an and. And how about the second one? Is there an or in between? No. So automatically we know that this is also an and. That means that whenever we graph them, they should be crashing against each other. Correct. So what should be my first step? What's usually our first step every single time? Correct. To draw the line. But now, because we have 2 inequalities, one here and one here, we actually going to draw 2 lines. One on this side and then one to the other side. And now our purpose still stays the same. Whenever we're solving, our purpose is to be able to leave the x by itself. That's what we want to do. So therefore, I'm going to move my 1 to the right, becomes a -1, but also I'm going to move it to the left. So we're going to move it to both sides because now we have 3 sides and we want to leave the x by itself. So therefore, the 1 goes to the right, but also the 1 goes to the left. We have a -4 is less than x, which is less than +4. Remember, same signs you add, keep the sign of the bigger number. Different signs subtract, keep the sign of the bigger number. And that is my solution. We left the x by itself, which is what we wanted to do. Easy as that. But now we need to graph it. So let's go and place our number line. Let's go and make it 12 spaces, just as we've done before. If you have larger grid, you probably don't have enough space for 12. So you just want to make sure that you have enough space for the -4 and the +4. Let's see, 1, 2, 3, 4. That's -4. And let me place my arrow on the left. That means that the negative numbers on the left. And 1, 2, 3, 4, +4, and the arrow. So then I need to decide, open or close. Is it open or close on the -4? It's going to be open. And how about on the +4? It's going to be open as well. Now we can take the time to graph each one, but we automatically know that if it's connected, it should be also connected. So therefore, now if I graph it, x is less than 4, all the numbers on the left. Do you agree? And now, in this case, we have to read it backwards. It says x is greater than -4. Or if you want to take the time, we can also take the time to rewrite it. Let's rewrite it on the left-hand side. My x here, my -4 on the other side. Is the greater sign towards the x or towards the -4? Towards the x. So therefore. So we can read it backwards or we can take the time to rewrite it. Either way is fine. We'll be crashing against each other. That's an and. And you'll notice that they're connected, so automatically your graph should also be connected as well. So it's a very easy process. The only difference is that we don't have one side, we don't have two sides, we have three sides. We don't have one red line, we have two red lines. One here and the other one here. And the whole purpose is to be able to leave the w by itself. So therefore, I need to get rid of the -4 and the -3. Which one should I get rid of first? Correct. The -4. Move my -4 to the right and to the left. So that becomes a +4, and that becomes a +4. That gives me a -3 is less than -3w, which is less than or equal to 6. And now one last step, which is to divide by -3. I want to divide by -3, divide by -3, divide by -3. My 3's cancel, my negatives cancel. But because I divide by a negative number, what do I need to do? I need to reverse by inequality. So I need this one is a less than, becomes a greater than. That one is a less than, becomes a greater than or equal to. Now, -3 divided by -3 becomes a +1. 6 divided by -3 becomes a -2. Now, at times, you'll notice that we rewrite this because we usually want the negative number on the left, but for now, we're going to leave it as that. But you'll see as some of your answers, you might want to rewrite them. But for now, we know that's connected. So let's go and write them down, and your graph should be crashing against each other, correct? Oh, -2 and 1, so I'm going to place my 0 in the center. My -2 will be over here, and my +1 will be here. So I need to think. 1. Well, let's try the -2 first. Open or close? That should be close. And all the numbers that are greater than -2 are to the right. The 1 open or close? The 1 should be open. And all the numbers that are less than 1 are to the left. Remember, if you know that they are if it's an and they're connected, we might as well just connect them. We know that they're going to be connected, so we don't have to even think about it. I usually just connect them, and that's it. But it should match. And now let's go back and highlight the answers. Is -4 part of your solution? No, because there's no equal sign. So I'm not going to highlight -4. How about +4? Is that part of the solution? No, because there's no equal sign. How about on this side? Is -2 part of the solution? Yes. I'm going to highlight -2, and that's what we place as close to indicate that that's part of the solution. And is 1 part of the solution? No. You have to remember that whenever it's an and, whenever they're connected, your graph should be connected. So let's try example number 2. Let's go and make a line through, and then we just have example number 3, and that's it for today. Example number 2. So in example number 2, we're going to solve and graph once again. We have A and B, so make sure you write small. Otherwise, you can do one here and one underneath. I prefer to write small so we can fit both columns next to each other. We have -2a minus 6 is greater than 2, or, and I'm going to place it in red, a divided by -2 plus 3 is less than 2. The second one, actually, let's go and place the second one underneath because I don't think I'll have enough space here. So let's go and solve the first one. Whenever we have an OR, we're basically just going to solve them separately. We're going to solve the first one, and then we're going to solve the second one. And our answer will have an OR in between, so therefore they should be going away from each other. So let's try the first one. What should I do to solve the first one? Correct. Draw the line. I need to be able to leave the a by itself. So I need to get rid of the -2 and the -6. Which one should I get rid of first? Correct. The -6, move it to the right, becomes a +6. That is a -2a is greater than 8. And the last step is to divide by -2. My divide by -2, divide by -2, my 2's cancel, my negatives cancel. But because I divide by a negative number, I have to reverse or flip my inequality. That a comes down. 8 divided by -2 is -4. And now I'm going to solve the second one. To solve the second one, I'm going to move my 3 to the right, and let me draw the line. Move my 3 to the right becomes a -3. That gives me 8 divided by -2, and that gives me -1. And what is my last step? Is to divide by, not to divide. What is the a and the -2 doing? They're dividing, so the opposite is to multiply by -2. My 2's cancel, my negatives cancel, and because I multiply by a negative number, I have to flip the inequality. So it gives me a. -1 multiplied by -2 gives me a +2. So let's go and graph it. And I'm going to graph it on the right, so I have enough space for my next problem. So let's go and graph it on the right. Let's see, we have 2 and 4, so I'll place my 0 in the middle. We have +2 and -1, 2, 3, 4. Remember that you don't need to write down every single number. And now, on the -4, open or close? Open. And all the numbers that are less than -4 are to the left. Add 2, open or close? Open. And all the numbers that are greater are to the right. So remember that every time it's an OR, going away from each other. If it's an AND, so in this case, an OR, move it to the right and to the left. Example B. You should have enough space right underneath to be able to work on example B. On example B, we have -2 y minus 1, which is greater than 4, or, and I'm going to place my or in red, we have 7 is less than or equal to 4y minus 5. So remember that ORs are the same, but we just have two separate inequalities. But when we graph it, they should be going away from each other. So first step, go ahead and go through the process. Go and solve the first one. Go and solve the second one and see what you get. And then we can compare our answers afterwards. Go and pause it. You got it? Excellent. So what property should I use? I notice that I have parentheses, so I'm going to use my distributive property. And I do want you guys to be able to circle your -2 that you're going to distribute in red. And remember, do not just circle the 2, also circle the negative. -2 times y is -2y. -2 times -1 is +2. And now I can solve. Move my 2 to the right, we can say -2. -2y is greater than 2. And the last step is to divide by -2. But whenever I divide by a negative number, flip it. And now the 2's cancel, the negative cancels, so y. And notice that is the first thing that I do. Every time I notice that I divide by a negative number, I flip the inequality first before I do anything else. That gives me -1. On the second one, I'll move my -5 to the left, we can say +5. So it gives me 12 is less than or equal to 4y. And the last step is to divide by 4. Divide by 4, divide by 4. The 4's cancel. Therefore, I have y is greater than or equal to 3. So notice that you can read it backwards. Y is greater than, because the greater side is towards the y, or equal to 3. But we do need to be able to rewrite it. So therefore, the y is here, the 3 here, and the greater is towards the y, so therefore I'll place the greater towards the y. And now let's go and graph it on this side, or we can place it underneath. Either one is fine. I'm going to place it underneath since I do have a little more space. Number line. We have our 0 in the middle, 1, -1 here, -3 here. And now I need to decide, is the 1 open or closed? The 1 is going to be open. And all the numbers are less than, or it's +3. It's to the left. I knew there was something going on because I said, hold on, they should be going away from each other, right? That's not -3. You probably noticed that before I did. And 3 is here. And open or close on the 3? Close. And I'll be to the right. And I'm going to highlight the answers. So all of the answers can be on the left, but 9 including -3, excuse me, -1. -3 is the solution, but -1 is not because there's no equal sign. And how about on the right? Is 3 part of the solution? Yes. 3 or anything to the right. And let's try the last example. See if you understand. So therefore, we are going to make a number or margin 2, 4, 6 on the right. I need a little more space, so I'm just going to make 7 squares all the way down. Make sure that you guys are using the ruler. You have example number 3. Solve and graph. And we have A and B. See if we can fit them next to each other. If not, we can do it. We probably can do it underneath. We have enough space. You have 2c plus 3 is less than or equal to -5, or 2 minus c is less than -1. Go ahead and solve it. See what you get, and then we can compare our answers. And well, before you actually do it, is this going to be crashing, or is it going to go away from each other? Or should be going away from each other? Okay, go ahead and pause it, solve it, and see what you get. And then we can compare our answers. So in this case, you got it? Are you sure? Excellent. So in this case, draw the line. I'm going to leave the c by itself, so therefore I'll move my 3 to the right because I say -3. And now I have 2c is less than or equal to -8. And now I'm going to divide by 2. Divide by 2. My 2's cancel, so therefore I have c is less than or equal to -4. And this is one of my answers. Do I need to flip the inequality? Do I need to reverse it? No, because I divide by a +2. I don't need to flip the inequality. Next, I'll move my 2 to the right because say -2. I have a -c on the left. And the last step is to divide by negative, or there's a 1 hiding from us that we can actually place it in there. So now we can divide by -1. My 1's cancel, my negatives cancel, so therefore I have c. And whenever I divide by a negative number, I have to flip it. Negative divided by negative is going to be positive. It'll be +3. Now, when I graph it, should be crashing or going away from each other? Correct, going away from each other. So therefore, I'm going to put my number line underneath. I have 0, 3 on the right, -4 on the left. And open or close. So in this case, on the -4 should be close because the -4 is part of the solution considered an equal sign, and all the numbers that are less than -4 are to the left. Remember, or should be going away from each other. C is greater than 3, so be open, and all the numbers that are greater than 3 are to the right. Last example for today, B. So for letter B, we have 1 is greater or equal to 2x minus 3 greater than -8. So before you start, you need to decide, is this an and or an or? This is a and. They're connected, so automatically your answer should be connected, your graph should be connected, and this is an and. So even though there's no word inside that says an and, we know that that's an and because they're connected. So go and solve it, see what you get, and then we can compare our answers. Go and pause it. So in this case, I'm going to draw the line. I need to be able to leave the x by itself, but first I notice that there are parentheses. So what property should I use? Correct, distributive property. So therefore I have 1 greater or equal to 2 times x gives me 2x. 2 times -3 will be -6. And now we have an easy two-step equation or inequality. I need to get rid of the 2 and the -6. Which one should I get rid of first? Correct, the -6. So therefore I'll move my -6 to the right, becomes a +6, and to the left becomes a +6. So you move it to the right and to the left. And now that gives me 7 is greater or equal to 2x, which is greater than -2. And the last step is to divide by 2. So therefore my 2's cancel. I have x, -1, and on this side it's an improper fraction. So I can change to a mixed fraction. 2 goes into 7 how many times? 3. My denominator stays the same. 3 times 2 is 6. To get to 7, I need 1 more. And now we can just graph it. Let's go and place a number line. I'm going to place my 0 in the middle. -1 on the left. And 3, 1, 2, 3, and 1/2 is here. 3.5, correct? So therefore, automatically they should be crashing. So I know that they both are open and they should be going towards each other. Let's see, do we have time for another example? I think we do. Let's go through a line, and the next ones will be short. So let's go through example. I know you said yes, you said that was the last one, I know, but we do have the time. So let's do example number 4. And what we're going to do, we're going to rewrite this as a compound inequalities. This is a number C is less than 5 and we're going to write down just 5 and greater or equal to -2. So therefore, we need to be able to rewrite it as a compound inequality. So let's see, I need to decide, is this an and or an or? Well, in this case, well, we're going to say yes, there's an and an or. Which one is it? So in this case, a number C is less than 5 and, so let's go and circle and, that's going to be an and, greater or equal to -2. So the number is C. We're going to place C in the middle. We always place the smaller number on the left. So -2, and the bigger number will be 5. And let's see, we're going to start with the 5. The number C is less than 5. So less than 5, correct? and C is greater than or equal to -2. So the C is the one that's greater than. So therefore, the C has to be the greater than or equal to -2. Or if you want to rewrite it, we can see C is greater than or equal to -2. Do you see that those two expressions are the same? But this should be connected. Let's try letter B, and that'll be the last example. See if you can do the next one by yourself. B. We have a number x is less than -1 or greater than 4. So first, is this an and? Go and finish copying it. Pause if you need more time. So I need to think, is this an and or an or? This is a or. It tells you right here. So let's see. We're going to place on an or, we basically just place that word or in between, and we write two separate inequalities. The first one is the number x is less than -1. So x is less than -1. And the second one, the number x is greater than 4. So x is greater than 4. So in this lesson, it is essential that you need to be able to remember whether it's an and or an or. If I was going to graph this one should be connected or should be going away from each other. So this is the lesson for today. Please email me if you have any questions. Have a great day, and I'll see you guys next time.